Hello, I'm JW, and in this video it's equipment repairs or refurbishment time, and the piece of equipment in question is this electrical heater just here, and this is probably from the 1960s, possibly a bit older, and it does actually still work, but of course it's allowed all the original parts, and 50-year-old electrical wires and things are not necessarily very safe, so of course they'll need to be replaced. So we'll have a start by just having a look inside and seeing what kind of state it's in. Now here's the heater and metal case, metal grill as well, and two knobs on the front here, just the one for the fan, so off 1, 2 and 3 for different speeds, and then the same for the heat, off 1, 2 and 3. Now this is a metal base here as well. You can just see the three-bladed fan inside there, and a little presumably a neon indicator on the front panel there. And as you can see, it's made by EMI, and on the bottom I've actually got the markings things there. That's actually upside down, little rubber feet on it, and around the back there just the air inlet. This is presumably going to be the reset of a thermal cutout on there, and a label here just for some safety information. And rather bizarrely, somebody has put this label on here, and what this appears to be is they've actually gone through the various settings, as in sort of off 1, 2 and 3, and then the fan speeds, and they've actually written down the current and therefore the wattage that the thing takes when it's in operation. So that's a close look there, and as you can see we've got sort of on the first here sort of 0.065 amps and 15 watts all the way up to 8.2 amps and 1968 watts. So a rather strange thing to put there, and obviously whoever put this on must have taken a fair amount of time to actually go through all of the various settings and measure the current and work out the power on each one of those. Now the base is also metal, and the cord just goes in there. See, it's rather frayed and damaged there, so of course that's going to have to be replaced. And on the top there it's got this white plastic handle, and a chrome plated metal trim just goes all around the various sides. So first thing we need to do is to open this up. Now in terms of actually opening it, it doesn't have any majorly obvious things on the sides here, and there's a single screw on the top, which not totally clear what that does, so I think we'll go for the screw on the bottom here first of all. Let's see what we can find by removing that. I've got these sort of sprung tabs here which to release the base like that, and so it just was just that single screw there. Now, well, we've just got this off here. Let's just have a look at this metal plate here. I don't know if you can see there with the angle, but first we've got model CRH7, the Gramophone Company Limited, made in Great Britain, and then the rest is just basically sort of safety information, and also don't cover the front when it's in use because it will set on fire. And rating here is 230 or 250 volts, 2 kilowatts, and the serial number of this one is GP117443. Now on the bottom here we've got the cord, this sort of fabric covered material stuff, and it comes with this single grommet flex grip here, and then just the three cores coming out here. So we've got the green, which will be the earth, line will be the red there, and of course neutral being the black underneath there. So line neutral in there, and then the earth here seems to be onto the metal frame, and there's got an additional wires which for some reason are insulated, which is rather strange, but anyway, one goes down to here and another one goes up inside into the top part somewhere. So the first thing we'll do is just undo these three nuts here, and we can just remove that old wiring. So just loosen that, make sure we're able to extract the wire from in there. So quite nice to have actually put the sort of crimped on circular lug there onto each one, rather than just shoving the wires into the mechanism. And that's rather loose already there, so that's not very helpful. So just loosen off the other screw there, and I'll take the cord out. Okay, that is moving, so what we'll do, I think we'll just cut it where that damaged part is. So that's the cord removed, and actually it's just a 3-core flex there, the old black, red and green colours, so obviously prior to 1970, and those were just obviously matched up onto the terminals up there. And notice it's, so we've got these other earth wires going up inside the casing, and those two of course on that ceramic insulating block there, so they're obviously not going to short onto the metal outer case. Now for the rest of it, there's 4 screws under here which appear to contain the base onto the top. So we'll remove those because the base, this is presumably in 2 halves here, and obviously this is joining them together, so it seems pretty inevitable that it's going to have to come off. And notice all these are slot-headed screws, so all assembled by hand. Cross-headed things are primarily only used for machine assembly because it's much easier for machinery to do those up. So the base should lift away there. Now we've got this wire here which I may well have to disconnect, but certainly the outer trim has come away there. So that's just chrome plated, and it is metal, not just some crap plastic as you would expect these days. So obviously we'll keep that, and presumably we're going to have to remove all of the wires from this stud, otherwise obviously we won't be able to get the casing away from there, so let's just disconnect that. Now see there's another screw here which presumably is the end of that wire, so let's just undo that as well. Right, so they've just looped that wire there, and just also looped it there as well, so it's all part of the same piece. That seems a bit crap, considering they went to the bother of putting those nice rings on the other one. And then this one, they've just literally twisted it around the screw and shoved the nut on the top. So yes. Let's just see if this is going to separate. Now we do have this other screw at the top here, which presumably is holding the other side together. So we'll get rid of that. Right, that's definitely loosened something. So it seems the back panel is totally separate there, and all of the works are mounted in the front. So let's just make a bit of rearrangement here. So there's the back plate there, just the pressed out steel, and the inlet grill. Not too bad inside, a bit of dirt on the bottom there, but certainly not caked with grime as you might expect for a 50-year-old thing. And just 2 screws there holding the plastic handle in place. And this bit here, the spring there, that's just that red button on the back, which presumably is a thermal cutout reset. So if you did cover the front up with a blanket or something, it would switch off and hopefully not set the place on fire. So here we have the inside. So the earth wire here is this covering this brown covering here, and that's going to go up to a stud on the side there, and also comes across onto the front of the motor assembly there. So it seems reasonable, although why they've bothered to put insulation over it's not totally clear, because given it's earthed anyway, it's not going to have any problem of shorting onto the case, because of course it's already connected to that. Now the power comes in here. I've got your line and neutral there, and so that's the power indicator there on those red wires just connected directly across the supply. That just goes straight through the front panel, so it's probably a neon in there. It certainly won't be an LED because they hadn't been invented when this thing was made. And then the others here, we've got this side which was the neutral, and that goes up to the top, to this terminal block at the top here. And then the line here comes across to the switch there, and obviously then you've got your various outputs for the different settings on the front, so basically sort of 1, 2 and 3. And then the other side here, we've got another black wire here which goes up to the motor, and again comes back down to the switch on this side. We've got this rather massive resistor there, the 700 ohm resistor there. And this is actually the fan speed, so obviously they're just using a resistor presumably in series with it to regulate the speed, which seems rather inefficient. And so it's a bit evil to see there, but we've actually got 3 leads on that resistor there. It's got one at the top here, one in the centre, and then one at the bottom. So when it's switched on, it's either going to be a straight through connection to the motor for full power, one of the resistors in series with it, or both of them in series with it. I'd say rather efficient, and hence the power wastage of the there's going to be quite a lot, hence it's rather large physical size. However, though, considering it's a heater, the bit of extra heat there is not going to actually make any difference. The elements themselves are just these coils in here. It's a fairly standard arrangement. There's probably mica separator plates there, and let's go around in that sort of round pattern. And there's several layers, so we've got 2 here, and then there's actually more behind that as well. Notice they're offset to get the maximum airflow across those. Very standard motor in the middle there, probably one of these shaded pole affairs, and it looks like the shading rings in there. And that will be the thermal cutout at the top here, which presumably when it will Alright, that's quite ingenious. Let's have a closer look at that. So this is the thermal cutout here, and as you can see, it's these are the wires that go to the heating element, so one on each side there. And one of them, of course, goes via this contact, and this is a bimetallic strip. And that red button on the back actually would have pressed onto this side of it, like that. So in this position it's normally closed, which is how you'd expect. And obviously if the heat in this area increases to a certain level, it will cause this thing to heat up, and then the strip will bend, and as it bends, it will push this way, and then it will spring apart, breaking the circuit. Now this is actually magnetic, so once it's sprung apart, it will actually stay there with the contact broken, and then the reset button will press onto it and just cause that magnet to move a bit closer and reconnect the circuit there. So very simple mechanism, but of course very effective. Now the main body of the thing, of course, will need to be cleaned. It's not actually too bad. It appears this heater has not had a great deal of use, as typically this type of thing you'd find would be completely caked with dust, but in this case relatively clean, a bit around the motor here where some dust adhered onto the various surfaces, but they're pretty remarkably clean, in fact, for something of 50 plus years old. So I'll clean out all the dust in here, and I'll speed this section up, of course, because this may take a while. Now I've cleaned away most of the dirt and rubbish there, and although it's not 100% spotless, it's certainly far better than it was before. And the blades actually do spin fairly freely anyway, so no major problem with the motor there, because I didn't want to particularly dismantle the whole thing in there. And see on the back of the motor here, it's got a little hole there to put the oil in, so I put a couple of drops of oil in there. And I've got to use this oil here, which is not actually intended for the particular fan there, but it's for the organ just over there, so that will do just fine. It's motor oil anyway, so take a couple of drops in there just into the bearing at the back, and so they rotated quite freely anyway, even before the oil was put in, so no problem with that. Now the wiring inside isn't actually too bad. We've got these 2 black wires here, which are obviously for the motor here. This one is just directly there. The other one obviously via this resistor arrangement, so you can get the various different speeds, say 3 speeds here, so it's either direct on or with one or both of those 700 ohm resistors. And so they're reasonably okay there, and they actually appear to be plastic coated. They're not actually rubber, unlike the flex which came in, so quite happy just to leave those as they are. And of course they're well away from the heating elements anyway, they just obviously come down, and the heating element obviously at the top, so not a problem with the heating on those ones. These wires here, though, which are the ones which go from the basically the supply via that little cutout switch at the top, and then obviously come back to the switches here and the rest. These are actually just bare wires, it seems, with this fibre or some kind of heat-resistant sleeving over the top, and this has actually gone rather sticky and fairly unpleasant. So I think we'll just replace those bits of sleeving, and of course this does need to be heat resistant because obviously it's right up here in fairly close proximity to the elements, and although the air's coming in the back here, which is cold, clearly the elements are right there and the sleeving is here. So those two I'll replace. This one here I'm not particularly bothered because this is actually the earth anyway, so if we're going to replace those, then there's not much point in changing that, and I don't really see why particularly that one's got covering on anyhow, because it's all connected to this metal work in any case. The wires here at the bottom are actually just bare conductors, but they're actually rigid and well fixed at either end, so although they're not insulated, again, that's not a major problem because of course they're not actually going to be moving anywhere. They're pretty much solidly attached in place. And at the bottom here we've got the three insulated terminals there, which are for the heating elements here, and there's three of them because we've got a common here, just may have seen that it's got two of the wires attached here, and essentially it's got three heat settings. So we've got one of the elements powered, which will be doing those pair, the other set, which is going to be that pair, and then for the full heat it's going to be both elements activated, and also that's still the common one over there. And it's going to be arranged so that the two elements are not the same rating, one of which will be a higher rating than the other, so then you've got to do a 1, 2 and 3 heat setting. Now the back cover cleaned up perfectly well, and I've removed that label which someone had stuck there with the various readings and information on the current it draws at various settings, because that seemed to be fairly pointless. And if you do get anything like this with labels stuck on, do not attempt to just peel the label away, because that usually results in the paint being ripped off, and of course that's pretty much irreparable. The proper way is just to soak it with water. I'll just put this under the tap for a few minutes, or if you can't actually put it under the tap, just put a wet cloth on the top and leave it for like half an hour or something, and then you find the paper will just easily brush away without damaging the paint underneath. The inside's say a bit grubby from the sort of heat damage basically, but not a major problem, and obviously you're not going to see that in any case. So these are the two insulations which I'll be replacing. So what we need to do is just undo the screws at one or other end. I'll go for this top end because it's more accessible than trying to get down in there with screwdrivers and whatever. So I can just remove that. Now this has a loop on the end here, so let's carefully straighten that without breaking it off, because also we want the wires to be the same length, because I've got to go back from whence they came. So straighten that carefully, and then hopefully we can just slide the sleeving off of there. I need to unthread it first. Yeah, so we can just remove that from there, and I see it's just a tinned copper wire underneath, totally bare and exposed. Now to replace it, I've got some new sleeving here, which is not so brand new, not been in service for 100 years or however long it's been in there for. So we'll use the old piece as a template, so just cut it to the exact length before sticking it on there. Now let's just see which wire this one is. Okay, well that's live, so we'll use some brown sleeving for that one. So I'll just mark the length there. See that the old is actually a bit smaller than the new one there. It's not a huge difference. And see the new one is totally flexible, whereas this one has got this sort of rather nasty stiff arrangement, and it's rather sticky in certain areas as well, which suggests it's decomposing. So we'll get rid of that, and then of course just a matter of sliding that over the wire down there, and again we'll just come back underneath, and then that can connect back onto the terminal at the top. So just form that loop back in the top there. And then we'll just screw that back onto the terminal on the side there. So as before, we'll just undo the screws there and unthread the wire. Undo the loop here. And again, that should just slide off of the inner wire. Now this is still live because though it's the other side of the switch, it's obviously just a switch, so it's still used the brown sleeving, and of course that matches the original colour as well. So again, we'll get rid of the old. Let's thread the new on. Goes underneath, and we just need to reform that loop on the end. And fix that back onto the switch terminal there. So that's those replaced. I say these bits here are not particularly concerned over because say these are the earth wires anyhow, so first of all, not carrying any power, and bearing in mind that if they short onto the case, well, so what, because of course they're already connected to that anyway, so we'll leave those pieces. Now the other piece here I'll replace is this one, which just comes over from the neutral there to this contact on the switch. It's a very short piece, but we'll change that anyway. And again, we'll take it off here at the actual switch because it's clearly much easier than trying to get down in there where those terminals are. So it's just a fairly short bit, and because it is the neutral, we use the blue sleeving in this case. So it's not the original colour, but it's the right colour for the colour coding today. So cut a piece off. I think you're not going to see it through the grill anyway, because of course it's down at the bottom over there. So just slide it on, and then we'll just redo that loop on the end of the wire. You just use the screwdriver, it's about the same diameter as the screw, so it's just handy to use to mould the wire around into the desired shape. And when you actually do loops like this, it's make sure the wire goes in the clockwise direction, so when you're tightening the screw it doesn't push the wire out. Obviously if it was the other way, as you tighten up the screw, it would basically undo the loop of wire, which could result in a bad connection. So just put the screw back in on that one. So that's the internals sorted out. Got the two new installations here, and obviously the blue at the bottom, and so I'm going to leave these two black wires for the motor, and so they appear to be PVC insulated anyway. And we'll just move that away out at the bottom there. Now another minor issue here, which I'm not actually going to be doing anything with. If you see this resistor here, a piece of the green is actually chipped off as I was cleaning it. Not a problem though, because this is just a ceramic inner, and that's just basically a paint or covering there with the rating on it. It's not actually exposing any wires or anything on the end, so not actually a problem, but unfortunately these things do happen. Now at the bottom here, of course, we need to attach the power cord, and pretty obviously we're not going to be using that power cord that we took off, because that's circa 50 years old, and rubber insulation and so on generally doesn't last that long. So get some new power cord, and we can just attach it to the three terminals here, and of course this is the earth which goes onto the terminals there as well. Now here's the power cord or flex we'll be using. This is rubber cable, and that's useful because it's a higher temperature rating, so if it accidentally got on the hot parts it's not going to melt through. And as it says on the front here, we've got 3 cords, and it's 1.5 square millimeters. This happens to be made by PX cables, but that isn't desperately important. So what we need to do is just strip that, and there's several ways of stripping flex. Generally though, the easy way is just to go in and slice down the length of it. Be careful not to slice right into the conductors, and if you get to the end there you can actually press a bit harder and then just cut right through, because if there's any damage to the inner part, well, so what, because you're going to be removing that anyway. And then just pull that off, and then at the point where you want it, you can just score carefully with the knife around there, again not going into the, or all the way through the insulation, and then if you pull it, then it would just tear off there without damaging the inner conductors. If it's PVC, you can actually score it and then bend it, and it would then crack around, but unfortunately that doesn't work with rubber, so it's score and wrench it off. So there's the three inner cores, of course new modern colours, brown, blue and green and yellow for the earth. Now in terms of cutting length, what we can use is the previous piece there, and just use that as a guide to cut the new to the same length as the old, and it appears that they're all pretty much the same length, so just use that as a guide there, and we'll just cut it to the end of the ring, because also going to have to fix some new terminals on there, so we'll just cut that to the appropriate dimension. Now I'll just strip off the insulation at the end of the three conductors. See there, these are actually tinned copper as well, they've got that shiny silver colour. Certainly not aluminium or some other dubious material, it is proper cable. Now obviously we need to put some ring terminals on the end in a similar style to those, and then it won't be exactly the same as those, and then of course they will just fit over those three threaded studs on the actual heater. Now here's the ring terminals there, just a standard ring there with the insulated barrel part. Now if you're going to use crimps here, you do need to use the proper crimping tool, such as this one, and so you've got the coloured holes at the top there for the various sizes. This one has blue, red and green. The green is actually used for the size that's smaller than red. They're not normally green, but whatever. And it has a ratchet in there, and it's also got properly shaped dies there, and it applies the correct amount of force. Now you may well have seen other things which have a sort of a handle, and then there's this sort of serrated bit in the middle where you can pinch your fingers, and then the top has this sort of weirdly pressed out bit of metal which you can attempt to crimp things with, usually known as the press and hope tool. They are useless. If you have one of those, then just throw it away, because it's a piece of junk and won't do anything. So just crimp these on there, so just a question of putting it into the properly sized opening, which is that one in this case. And crimp that closed, and of course just repeat with the others. Now the choice now is how long we want the flex to be. Now here's the old flex, so let's just have a quick look and see how long that was. That's 1 metre. Okay, so it's just under 2 metres, and bearing in mind I cut a bit off at the end anyway, so we'll just go for a 2 metre length, so just measure that out here. And that seems a fairly sensible choice, so we'll just cut that at the 2 metre mark. Now also this flex has to go via this clamping arrangement in here, so also it doesn't pull out and rip the wires from their terminals when someone trips over the lead. And we'll take one of these screws out completely, rather than trying to thread it underneath there, which is going to be a rather huge faff. So what we'll do is just thread that through the rubber grommet here. Just pull the flex through there. Now leave a fair bit loose there, so we can of course connect it to the terminals. Handily someone has marked here the colour code for the 3 wires, so we've got green, red and black. Of course that's useless because these aren't green, red or black, so, but in any case someone's also written it there, but we already know that this is the neutral here with the B for black, or it's actually going to be blue now because we've got that piece of blue sleeving in there earlier. And of course we know this is the line because we've got the brown sleeving that we also put on the other side. Now this post has several other nuts on there already to confix these other wires, so just make sure those are tightened down before we put the other on the top. So now just a question of attaching the 3 wires to the 3 terminals. So just place the lugs over there. In theory you could just put the wires under and trap them under that sort of metal piece, but it's a bit crap, so also we'll use the proper fittings. Now also need to put the flex under that clamping arrangement in there, so just move that underneath and then just put the other screw back in the other side. Now when you tighten these things, try to get them sort of equally tightened on each side, and bear in mind you're actually just there to grip the flex, not crush it and actually slice through it and cause it to be destroyed. So yes, they need to be tightened up, but on the other hand not so much that the cable is actually wrecked. So as you can see, that's holding that perfectly securely, so that's fine. Now this side also will put a new plug on there later, but for the moment what we need to do is to reconnect that earth wire. And this has got two connections. It's got the one which goes onto the stud there, and then obviously that will go on the top, and then there's this other piece here which fitted onto the other side of the casing. So I'll just put the rear cover back on, and that's just the two screws at the top here, and the chrome trim on the side just comes underneath through here and is basically just clamped in position there, so just a question of making sure that's pressed in while tightening up the final screw there. So then the final thing is this earth here. Now I've got the earth connected here, of course, from the bin stuff inside there, and this one also just goes over to that small hole in there. Now that just means that you've got both sides of the case electrically connected, because although they're both touching there also might be paint and other stuff around the other side. So, and of course that's how it was designed, so we'll obviously reassemble it in the same way. And again, this does have a bit of braided sleeve there, but so it's not really necessary because obviously it's all earthed together anyway, and it's also all metal in the same potential, so no problems there. And finally, of course, the plate there with the four little rubber feet, and just a single screw holds that one onto the bracket there, so just slide over these prongs at the end. And then of course the single screw and washer in the centre. So there we have it, all cleaned up there, and obviously just put the knobs back on, and these need a bit of cleaning, and this one I have actually glued this one as there was a crack unfortunately through there, so just wait for that glue to set and fix those on later. Now the final part is just put a new plug on. I've got a new black one here, and as you can see it's got the sleeved line and neutral pins, and obviously the earth is unsleeved. This one is supplied with a 13 amp fuse, which is correct for this appliance being around 2 kilowatts. So just loosen the centre screw there, and inside there we've got the 3 terminals, and also need to cut the end of this appropriately. So the first thing to do is just to cut along the outer like that. So notice that we haven't actually cut right through the insulation here, but have at the end, so we can now just peel it, and it will just pop open. Just stretch that back a bit, and then just score around here. Again, not going actually all the way through the white insulation, just putting a mark, and then we can just pull that, and that leaves a reasonably clean edge there. So get a 3 wires out there, and just check that they're not damaged there and you don't actually cut all the way through. So the next thing now is to place that against the plug and just cut the wires to the appropriate length. Now the actual white covering needs to go under that bar clamp there, so you don't want the wire down here because that's obviously going to clamp on the inner insulation, but again you don't want to go too far because there's a piece of plastic there which also will be in the way. So just put that in here and that will come over and around, so we'll cut that one. And I'm going to strip off a short piece of the insulation, twist those wires, and then the others, the earth needs to be fairly lengthy so that if it was pulled, the others would pull out first and the earth would remain connected until the end, so we'll make that as long as we can. And again, just strip the insulation at the end. And the neutral obviously would be a transparent in length, but as I fitted these before, it's going to be there. Obviously you could line up the plug if you were unsure. So I need to loosen these screws to get the flex underneath, so I'll just go in there and loosen those. Now you could just loosen them and try and thread underneath, but it's generally easier just to remove one of them. Just leave the other one on the side, and then we'll just undo the terminal screws, and then it's just a question of putting the various wires into the various holes, and this is actually marked L, N and E. That, if not, they're always in the same actual relative position. So brown over there with the fuse, and we'll just tighten that down. I notice all the insulation goes right up to the terminal, you don't want any bare wires poking out the bottom. Let's do the neutral next. Notice the pins can be taken out just to make it that bit easier to manoeuvre the wires in there. So just bend that around, slot it into the hole like that. And we'll just press that down into the recess there, and then of course the earth comes up to the top, and that just goes into the side like that. And again, we'll just tighten that down thoroughly. And the bar here, this has got a slot there for the cable to fit into, so just put that in there. Swing the bar over the top, and then just put the other screw in the side over that side. And tighten that down, and bearing in mind you're not tightening till you're going to crush it, just so it's obviously securely gripped there, so tight enough but not actually so it would damage the cable itself. So that's fine, and then we'll just go around and tighten those fully for the final connections. Make sure the wires are pressed down. And again, there shouldn't be any copper showing on the actual flexes inside. They should go right up to the terminals like that. And then finally just the lid to place on, and just secure the screw in the middle. So there we have it. We do come with this card which also indicates the correct wiring. Also we already knew that, so I didn't need to refer to that this time. Now that is all finished and ready to use, but of course in reality it's not ready to use because we need to check that it's actually safe first, because although we've done everything inside properly, for all we know there could be a stray wire or something hanging out, or we could have made some horrible mistake. So I'll just put the two knobs back on here loosely for now, so I need to clean those and obviously wait for that glue to set properly. And for testing we use this machine here, which I have shown in other videos. So I'm going to get in the plug and connect into the front there, and then we need to use this green wire, and this is to check that we've got continuity on the earth between the actual earth pin all the way through the flex and therefore to the metal casing of the device. So just find some suitable bare metal to attach to. That bottom plate will do. Obviously I'm going to attach it here because that's paint and it would damage it, and obviously it might not have a particularly good connection anyway. And the test we'll use in this case will be the one here. So it's essentially going to check that the continuity of the, or the resistance rather, of the earth wire is less than 0.1 ohms, and it will also apply 1250 volts between the earth and the line in neutral, and that shows there's no issues with the insulation. We haven't sort of nicked any wires or made some horrible mistake. So if we switch on the machine here, and it's important not to actually touch these things while testing because you don't particularly want 1250 volts in your fingers. So just press the button here and we should see the two green lights come on, and the meter here will indicate the earth resistance, which should be 0.1 ohms or less. Okay, that's fine. It's coming up in the sort of, well, it's well below 0.1, actually 0.1 is here, so that's well below. Now that was with the controls off, so we also need to do this with the controls on. So we'll turn both on there, and again we'll just do that same test once again. And again that's fine, you see it's green lights on, and again well below the 0.1 ohms that we need. Now we also know it's safe, so final test is just to make sure it does actually work, because if it didn't work that would be fairly unhelpful. And we can use the same machine for this, and this will actually display the current it uses when it's working. So just set the controls appropriately. We'll just try it with the fan on at the moment, just on the speed 3. And see the fan now is on, and the little red lights come on as well. Current's not actually hardly registering there, which is not surprising. It's just obviously a fan. And the fan goes at the various speeds there, and if we turn the heater part on, yeah, the actual current of the fan is, well, it's a fraction of 1 amp, so certainly very little. But if we turn on the heating part, and we should see the current increase here. So that's sort of 2.5 amps or so, and on the next setting that's around the 5 amps there, and the third one should be around 8 or so. That's showing yeah, a total of about 9 and a bit there, so it's a bit high, but then say the voltage here is not actually 230, it's more like 250. So there we go, and it comes out of it, and also we can turn that off, and that will just cool the elements and switch off. So there we have it, the EMI electric heater, all fixed and repaired, and probably good for another 50 years. So until next time, thanks for watching.